And we are live. Hi, everyone. Welcome to this flash course CT01. My name is Alex Villasana. I'm one of the founders and an instructor at the Innovative Bloom Company, or TILCO as we call it. At TILCO, our goal, our desire is to help our students cultivate their creative skills with the purpose of having a personal and professional life that is enriched. By this, we mean that we want to help our students to learn and apply what they're learning in a generous way so that their personal lives, their professional lives are enriched, that they and those around them receive the benefit of the application of what they are learning. So we want to help people under the umbrella of creativity. We want to help our students to develop these kind of personal and professional life, regardless of what their field of expertise may be. One way that we have in pursuing our goal is through these what we call flash courses. This is a very short introduction to a particular topic. It's a short video, something that maybe you can watch during your lunch break, something that you can use as a reference. It's a short video, as I say, not even an introduction, something on the surface, just to tease your interest, to provide one or two key concepts that may be useful for you. In this case, Flash Course CT01, we're going to be talking about computational thinking and software design. Another characteristic of Flash courses is that they are free. They're free of charge. You can watch it at any time, as many times as you want to. Also, the resources that we're going to be using for this flash course are free of charge. You can download them. Just follow the link. We're going to post the link in the appropriate place that you can download the tool that we're going to be using here, which is Allan, the paper computer. So let's talk about computational thinking and software design. Let me change the scene here and share my screen with you. Okay, here we are. So we have another video where we talk about computational thinking at some length, but here let me just remind you that CT is a formal approach to find solutions to a particular problem. That solution has to be easy to implement and easy to share. That's the way we define CT here at TILCO. Now, CT is becoming the standard nowadays to find the solution to problems, and this is because there is an interconnection among the different fields of human knowledge. They're intertwined, and our technological advancement is such that now CT is applicable to almost any field of any professional field. With that, what I want to say is that computational thinking is not limited to software design. It can be used in many other fields. In this case, for this course, yeah, we're talking computational thinking as it applies to the design of software. Now, this is the idea with the image that you're looking at here. You see CT that is overlapping or intersects software design. And in that intersection, we have what we call algorithm design. An algorithm is a recipe. Think about it as a recipe, the sequence of steps, very specific, very precise steps that you must follow in order to get the implementation of the solution or reach the goal that you're looking for. So CT helps us to design the algorithm. And then once we have that algorithm design, we can talk about coding. As you can tell by the diagram, coding is like the last step. You begin with computational thinking, you design your algorithm, and then you begin coding. Unfortunately, nowadays, a lot of schools, a lot of boot camps, a lot of different institutions that promote software design, they jump right away into coding without the context that we're talking about here. So it is important, if we're looking at producing code that has quality, that is good and solid, flexible, uh, and easy to maintain, we have to begin with computational thinking and algorithm design, and then we can jump into coding. So that is the first concept that we're going to address before we begin our practical session, or the practical part of this course. Now, the other concept that we need to consider is what is called a CPU, or central processing unit. Again, there seems to be a misunderstanding about this term. Many people believe that the CPU is the box that you have either under your desk or on top of it, where you have a lot of cables and you connect um, the screen, the mouse, the keyboard, the camera, etc. That is not the CPU. That box is not a CPU. Inside there is what is called a motherboard, and again, a lot of people think that is the CPU. Nope, the CPU, or the microprocessor, is this integrated circuit that it's on the motherboard, and it looks like the one that we have here on the screen. That integrated circuit, that central processing unit, is the computer. That is the real computer. Everything else are just peripherals. It's just things around the CPU that helps us humans communicate with the chip, and the chip to communicate with us. But the real heart, the real brain of the computer is this, and it's probably this big nowadays, this circuit, this microprocessor that sits on the motherboard. Now, engineers, when they design the CPUs, inside they define different parts or different regions of the circuit to do certain things. There are sections of the CPU dedicated to hold memory, hold data. For instance, there's this memory that holds data. There's another part that holds the instructions that are being executed. There are other parts of the CPU dedicated to hold the result of what's happening with that data once we run these instructions, etc. So that is a key concept that we need to keep in mind as we move now to the actual coding part of this course. So CT, computational thinking, and CPU, central processing unit, those are the two main ideas that we want to keep in mind. Now let's go to here. This is Allan, the paper computer. Let me zoom in. And the idea of this paper computer is to have a representation of those different regions, different areas that we talk about that are inside the CPU. So you can think of Allan as a paper representation of a CPU. There are different sections here, so let's go over them. Of course, you see our branding here to the right, to the left. That is the name of a creativity camp that we host at our church. And this last summer, or this summer, still summer, this summer, we use Allan with our students at Camp Leonardo. We have a great participation, great results. So that's what you see there in the middle. You see the instruction set for this version of Allan is version 0.5, only 1, 2, 3, 4, 5 instructions, and then just more branding and the license that we granted, or that we used to publish this very small tool. Meaning you can check it out, Creative Commons. You can check out that license if you're curious, but it means that you can print it out as many times as you want to, and almost use it in any way you want to. There are some requirements there, but nothing to worry about. Now, the proper elements of Allan here are these 4 sections you see: the program memory, register A, register B, and then the data memory, representing the different sections of a CPU. On the program memory, that's where we put the instructions that are going to be executed sequentially. Then on the data memory, you put the data that is going to be manipulated by the program. The first distinction that you can tell, besides the color, the first distinction that you can tell between these two memories is that the data memory has an address. So you can make a reference, a direct reference to one data cell and either read what is in there or write on that cell. So you need that address. It means that you can access this memory in any way you want to, in a direct form. It doesn't have to be sequential, since you can right away go to address 009, for instance, and you don't have to go 1, 2, 3, 4, 5, all the way until you reach number 9. You can jump right away to whatever address you have. Now we have register A and register B. Those are specialized memories. They hold data, they do things, and to find out what they do, we read the instruction set. The instruction set, you have 3 letters for each instruction, and then maybe a parameter, it may be an address, it may be a value and an address. And you can see the description here of what each instruction does. Okay, so the challenge for us, and let me get some text here. The challenge for us is to find, to write a piece of code that calculates 3 plus 7. Oops, I don't think you can see that. Let me move it. There we go. 3 plus 7, and let me make it a little bigger. So that is, and change the color, of course, that is the goal. The goal is to write a piece of code that calculates 3 plus 7 using only these instructions. Now, number 3, the value 3 must be on address, let's use address 007. No, that's going to be confusing. Let's go with 005. So the value 3 must be on 005. The value 7 must be on 013. And the result, we're going to put it on, let's go to 019. Okay? So that is what we want to do. So the value, sorry, the value 3 goes on 005. Let me make this a little bigger. Value 7 goes on 015. We're missing an arrow here, okay? And then the result goes on 019. So that's the challenge. How do we do it? We will be tempted to, because we know that 3 plus 7 is 10, we will be tempted to write 10 right away on address 019. And there is an instruction that writes, you see it right here is the last one, WRT, write. We write a value and an address. So we may be tempted to say, oh, this is kind of easy. We just go here and we say, write. And for this one, I'm going to change the color just to make it easier. Write the address 019 and then a 10. And that's that. All right, we can we may be tempted to do that. However, we want the computer to do the calculation. And this is, by the way, one of the answers that we got from our students. Right away, say, oh, sure, write the value 10 on the address. Oh, nice. It's another way around. It's 10, and the address is 019. There we go. It's value and then address. So value and then address. So that was what our students wanted to do. That is not a way to solve this problem. So how do we do it? Well, first, we have the data, right? 3 and 7. And we need to place that data in specific cells on that data memory. So there is the same instruction we were using, write, value, and address. And that's what we can use to proceed here. Write what value? 3 on what address? 005. This is the first thing. We must give the computer the data to work with. As you can imagine, the next instruction will be similar. Write, what is the value? 7. What is the address? 015. So far, so good. So once these instructions are executed, here on this cell, we have the value 3. And here on this cell, let me get another, on this cell, we have the value 7. So that's where we are. So we're writing and executing the instructions. What's next? How do we add those two numbers? Well, there's an instruction here that says add, but it's very specific. See, it has add and then an address. So add the content of the registers and write the result in address. If we jump right away here and we say add 019, what the instruction does, it takes the value on register A, adds the value on register B, and the result goes on the address that we're specifying. If we execute this instruction right now, what is going to be written on 019? 0, because both A and B are 0. Technically, you may say, well, they are undefined, which is true. Then what is going to be written on 019 is undefined. But let's go with 0. It makes things easier. So this is not the instruction that, oops, so sorry. This is not the instruction that we need. I'm going to put it right here. Because eventually we will need it, but not right now. So there is an instruction that reads, right here, it reads an address, and whatever that address contains, it places that value on A. Then there is another reading instruction that reads an address, and whatever that address contains, puts it on register B. So we need to bring 3 and 7 from the data memory into the registers. So the instruction is really here. Now that we have the data in the right place and the data memory, we need to bring them into the specialized memories called register A and B. So RDA for reading A, or reading into A. So we're going to bring 005 on A. And then we're going to read into B 015. So what happens if we execute these two instructions? As you can imagine, as you can see, not imagine, this is engineering, this is not art. The value 3 will be an A, and the value 7 will be in register B. What have we done so far? We have specified the data and put it in the location that we were told to. Then we have retrieved that data and put it in the special places needed for the calculation that we are trying to perform, 3 plus 7. Now that we have that, we can actually do the calculation, and that will be add with an address, because this instruction add, the only thing it does, it adds whatever is in A plus whatever is in B, and the result, it places it in the specified address. So here we are. After we execute 8019, what we have is the value of 10 right here. And that's that. That is our program. So what we have done, we have, and before that, if you think that this is painfully slow or that is like, well, this is too much detail, it is true. That is the way software is designed. This is the way a program is written. We have to tell the computer everything. So we follow the specifications. We put the values that we were giving in the addresses that were specified. We calculated the formula that was requested and put the result in the specified address. Ta-da! That's that. Now, if you want to challenge yourself, and by the way, of course you can use Allan uh, for yourself. If you're learning a little bit more about computer programming, you can use it, as I say, as many times as you want to, download it, print it out, or what some people have done, they have laminated it and they use dry eraser markers. In that way, there's not that much waste of paper. Other people have put them into sleeves, those 3-ring binders, sleeves, and it works the same. You can use a dry eraser, one of those markers, dry markers, to write on it, and then you can erase it in that way. Again, we avoid waste, but it's up to you. And if you are either a teacher or a parent, you can use this with your students, with your children's. With your children, it's a good tool to introduce students to this idea of we need to think, we need to take our time to think, to find the solution of a problem. So before we go, let me give you a challenge. What about writing a program that calculates 12 minus 4? And again, let's change the color of this text, and then let's make it a little bigger. What about that? What about a piece of code? I'm looking at the screen here. What about a piece of code that calculates 12 minus 4? Well, there's an instruction for that, is sub and the address, similar to add and the address. However, you have to be careful, of course, because it will subtract what is in B from what is in A. So you have to be careful where you place those values, because 12 minus 4 is not the same as 4 minus 12. You have to be careful with that. In this case, 3 plus 7 and 7 plus 3, there's no problem where we put the 3 and the 7, meaning A or B, doesn't matter. But for this challenge, it will matter. Have to be careful. And write it down. Write your code. If you want to share with us, yay, that will be great. But yeah, there's no specification of address, so you can put the 12, the 4, and the result, whatever you want to, whatever your student wants to. There's only 19 addresses, and I'm just realizing, actually, the very first address should be 000. But again, we will fix that in the next version of Allan. So let me go back here. And let's just chat here for a moment. We are done. That was, as you can tell, very brief introduction. Not even an introduction, just some commentaries about computational thinking, software design, microprocessors, algorithm design. So we hope that this flash course is of use, it's useful for you. If you have any questions, if you have any comments, please let us know. We are curious if you are using Allan, the paper computer in your classroom, if you're using it as a homeschooling tool, or if you're using for just personal benefit, whatever it may be, that whatever the application may be, or maybe you have other applications besides these three, we would like to know. We will love to know how you're using it. And I will finish with this. This is version 0.5. We have plans to expand this idea, to write a little a guide or a little booklet with instructions how to use it. And of course, we will publishing more videos about it. So please be tuned, be aware of when we come and post these videos, this information in our social platforms and social networks and on our website. Okay, well, thank you so very much for your time. Again, I'm Alex Villaseñor. I hope this was useful. Let us know. Let us know. Okay, thank you.